Hi, Dr. Gores.
Tyler, welcome to the pre-class video. And what we're going to be learning about in class are voltaic cells, electrochemical cells.
Volt, like electric.
Exactly. And so a voltaic cell is a way that chemists have of separating out two half reactions so that they can study the energy of the electrons that are transferred in a redox reaction. And it's kind of a cool setup. So this is just a little drawing of a redox reaction. Some copper ions in solution, 8 ways copper, aluminum solid. Turns out aluminum is a really good reducing agent, and the aluminum is going to reduce the copper, and it will form little chunks of copper metal that get plated out on the surface of the aluminum, and some of the aluminum ends up getting dissolved to form aluminum 3 plus in solution. Ooh, that's really not drawn very well. Right? So that's a redox reaction all done together, and we can't really follow the electrons there because they're just transferring between things. Right? And so the electrochemical cell, we separate the copper in one system, the aluminum in the other, and we connect them with wires so that the electrons are forced to go through the circuit. And it's actually the basis of how batteries are constructed. So it's going to tell us a lot of information. So in class I said to remember, Leo says GER, loss of electrons to oxidation, gain of electrons is reduction. And the second part of that is at the red cat, because in the electrochemical cell, we're going to have a chunk of metal usually stuck into it called electrode. And there are two types, a cathode and an anode. And so this red cat means that reduction is going to happen at the cathode. So reduction happens at one of those electrons. And the cathode is a positive charge. The cathode is the positively charged electrode, so electrons in the circuit are attracted to the cathode, and that's why reduction happens there, because it has excess electrons. So, red cat.
There you go.
So those are the things you need to know to get started on the activity.
Okay.